All right, everyone, this is example problem 2 from lesson 25. We have a simply supported beam that extends out past its roller support, and we're asked to find the reaction forces at A and B. So just like the last one, we're going to start by drawing our reaction forces on here. So B is a roller support, so we only have a reaction in the y direction. A is a pin support, so we have both a y component and an x component to that. All right, if we go ahead and look, we have an 8-foot distance between points A and B. We have a 10-foot distance between point A and the applied force, and then we have this force applied at a 60-degree angle to the beam itself. All right, so again, statics problems, so we're going to start off the exact same way. We're going to look at the sum of the forces in the x direction, which we know is going to be equal to 0. So our first force in the x direction is pretty easy. It's AX, right, pointing off to the right. Now our second force is this 60 degrees, or this 4.2 kips at a 60-degree angle, right? So we need to break that up into x and y components. So the x component is the adjacent side to that 60 degrees. So it's going to be 4.2 kips times the cosine of 60. All right, and then that's pointing to the left, so that's going to be a negative force, and so the sum of those two is going to be equal to 0. Right, so then we go ahead, solve for AX. AX is 4.2 kips, cosine 60, therefore AX is equal to 2.1 kips. All right, so far so good. Next up, we do sum of the forces in the y direction. Start on the left and move to the right. We have our A sub y, we have our B sub y, and now we have another component of our 4.2 kips. So this one, we want the opposite side of that triangle. So we've got 4.2 kips times the sine of 60, and then it's a downward force, so that's negative. The sum of those three is equal to 0. So at this point, one equation with two unknowns, so we have to go ahead and do our moments. Again, we're going to sum about point A so that we can make A not be included in our equation. So we have sum of the moments about point A is equal to the sum of force times distance from point A is equal to 0. So we have AY times 0. So we're again going to say that counterclockwise is going to be positive moments. So BY is going to give us counterclockwise motion. So that's going to be a positive moment. And then the Y component of our 4.2 kip force is going to give a clockwise rotation, which is going to be negative. So we'll have plus BY, and our point B is 8 feet away. And then, negative 4.2 kip sine 60 times 10 feet is equal to 0. So we go ahead, plug everything in, solve for it in your calculator, and you'll get that BY is equal to 4.55 kips. Okay, now that we have BY, we can go back to our sum of the force in the y direction equation. AY plus 4.55 kips minus 4.2 sine 60 equals 0. This gives us that AY is equal to negative 0.91 kips. All right. Okay, so what does this mean? We got a negative number for AY. Well, all that means is that we drew it the wrong way in our picture. We drew it as an upward force. Turns out it's actually a downward force. All right. Well, what does that mean? Like all the pictures we've had so far have been all these reaction forces as being positive, right? Well, if you look at our picture, right, we have this 4.2 kip force pretty much pushing down on the right side of our beam. We've got our point B in the middle, and then we've got point A all the way on the left side. If you just think about what this looks like in real life, right, it kind of looks like a seesaw from like a playground, right? So if you're pushing down on one side of the seesaw, you got to have something that's holding the other side of the seesaw from going up. So that's what this AY being negative it means. It means your applied force is pushing down on the right side of our beam, and our pin at point A is holding the beam from moving up from there. All right.